I'm Dr. Naimul Khan. I'm a professor in electrical, computer and biomedical engineering here at TMU. I came to Canada as an international student, and I actually did my PhD at TMU before joining as a professor. I teach the Java course in second year in computer engineering, and an interesting fact about myself is that my handwriting is really bad, and a lot of students have said that, oh yeah, please can you rewrite this part of the code that you wrote on the whiteboard. So I have worked hard to fix it. I'm still trying to work hard for it, and I'm glad that I'm in engineering, that I don't have to handwrite as much. For me, computer engineering means betterment of the society as a whole. Again, as I said, like computer engineering has become increasingly important, especially over the past few years, and with the pandemic and whatnot. We started working remotely, so technology is playing an increasingly more important role in our life. So I would say for Canada's economy, for every sector now, computer engineering is becoming increasingly more and more important. Computer engineering is a pretty wide field, like pretty big field, right? So it's closely related to computer science as well, right? So I would say, like as you can see, even our department is called electrical, computer and biomedical engineering, right? So three programs are like clumped together. So computer engineering, they can do specialize in hardware, in computer architecture, in software engineering, which is now the big field, like in artificial intelligence, robotics, computer security. So that is also a big area now, right? With like with the advent of cloud computing and whatnot. So these are probably the biggest fields that people can specialize in computer engineering. If you have looked at recent computer engineering research, like if you just search computer engineering research on Google now, you will see that AI is the hottest topic, right? So I would say that in the next 10 years, AI is gonna rule the computer engineering world, right? So in every aspect, again, as I said, whether it's security, whether it's finance, whether it's healthcare, everywhere AI is gonna play a major role, and computer engineering is obviously a big part of the infiltration of AI into these different areas of our lives. In my research lab, what we do is, my research is mostly AI and its application in healthcare. So one of the projects we are working on is very interesting. So what we do is, with the Holland Bloorview Hospital and a local Toronto company named Shaftesbury, what we are developing is a therapeutic virtual reality gaming application for kids with autism spectrum disorder, right? So I think that project is probably not only for me, for my grad students in the lab. That is probably the most interesting and memorable project that we have ever worked on, because working with kids and developing therapeutic gaming applications that help reducing their anxiety. Like you right away see that hardcore engineering projects, how it's positively affecting people and positively affecting the healthcare field as a whole. So I would say that is probably the most memorable project that I have done in engineering. To give a background about that publication and how that work relates to computer engineering and healthcare. So in that work, what we were doing was essentially Alzheimer's disease. It's diagnosed through MRI scan of the brain, right? And from MRI, we usually try to see that how much of the white matter has reduced to predict the severity of Alzheimer's, right? So right now it's done manually by doctors, right? So the idea is that can AI help the doctors in differentiating between the progression of Alzheimer's, the severity of Alzheimer's, right? So this is a pretty big research area, and from that publication, we have, I'm now collaborating with the Mount Sinai Hospital in Toronto, where we're using similar things, right? Like for ultrasound images on premature babies, because Mount Sinai Hospital has a big neonatal intensive care unit. So they use ultrasound to diagnose different diseases from premature babies, right? So that project is also using similar types of algorithm, that how can AI help decipher different types of diseases and their severity through image processing, which is like a big part of computer engineering. Like if you end up taking like grad studies, you are likely gonna take courses in image processing, and then you will actually get to learn that how these things work, right? From engineering, from a technology. technology standpoint as well. The TMU Multimedia Research Laboratory. I actually did my PhD here as well, right, with Dr. Ling Guan, who is a professor in the same department, and then I joined as a professor. So we do our main work is, as the name suggests, multimedia research, right? So researching analysis of multimedia through AI, then multimedia communication, say over networks, and multimedia compression, and multimedia retrieval, all of these big research areas. So we have I have quite a few grad students in the lab now. I have like 6 PhD students, 5 master students, and so my students do most of the great work. And as I said, a big application area is AI in healthcare, and then another interesting application area that we work in is augmented and virtual reality, and they're all connected. Augmented virtual reality has some application in healthcare as well, and also in media, in analysis, in say planning, building planning, manufacturing. So these are all like related areas. So these are the 2 big research areas we are currently working on: augmented virtual reality, and then application of AI in healthcare. One example I already gave about the project that we were doing with the Holland Blue Hospital, right? So the main part I'm keeping an eye on is, again, like AI and its application in healthcare, right? So we do a lot of projects. Like one of the projects is the one that I gave example. Another one is computer aided diagnosis, where we analyze like medical images to diagnose a disease from them, right? So these type of projects are of my interest. So the use of AI in healthcare and how that can transform healthcare in future for us is what I'm closely keeping an eye on, and I'm very hopeful about that. I will divide it up into software and hardware. On the software side, it will be, again, as I said, AI, like not only the theoretical development of AI, but also the libraries that are being developed to deploy AI in a mass scale, in a more accessible manner in every application areas of our life. And on the hardware side, again, big development of this AI and software infiltration has been because of hardware, like the graphical processing units and stuff like that, like a big development in those areas. So computer architecture, then quantum computing, and in general, like graphical processing unit development of more powerful graphical processing units, and AI processing units, tensor processing units. So that will be on the hardware side, and on the software side will be development of different libraries that can easily deploy AI in mass scale. You know, as a professor, the first thing I always say is that, keep your grades up, right? So obviously that's a very easy advice to give. But other than that, I would recommend definitely do a co-op, right? Co-op is so important now because the field is very competitive, although there's a lot of jobs and a lot of opportunities after you graduate to work in computer engineering, but it's competitive as well. You're competing with many other people because the field is growing at a massive scale, right? So do a co-op, keep your grades up, and I would say try to think about things from a high level point of view, from like a system point of view, rather than just doing problems on paper. Because obviously you get hung up with exams, and in the exams you have to solve mathematical equations and problems, but try to think about like the big picture of things. Because when you go into professional development, a lot of the day-to-day things that you'll be doing, you'll be learning on the job anyway, right? But looking at things from a big picture point of view and trying to understand the human problem is a very important skill to develop. And again, some of it you'll develop through your co-op, but some of it's kind of internal growth as well as you go through your program. Even when you do your capstone project, try to think about the project from a big picture point of view rather than getting hung up on the nitty-gritty details. So that would be my advice. First year students, honestly, the easiest advice is keep your grades up, right? Because I know it's like easy to say, but difficult to do, right? Even me as a first year student, I even did not do that well in some of the courses, if I'm being honest, right? But yeah, like just focus and try to keep your grade up. But in addition to that, try to do extracurricular things as well. Don't force yourself that I have to do an extracurricular activity. Like do something that you enjoy alongside your academic advancement, right? Like our school have a lot of like hobby clubs, right? Like I know that some students have joined the drone development. Son has a drone development team, a racing car development team, and you can probably find a lot of interesting aspects of engineering that you can apply to like a competition or to join a club where people are developing something together. That will kind of show you that the academic things that you are learning has a direct application, and it's fun to do as well, right? So I would say these two, like keep your grades up, that's number one. Number two is try to join in an extracurricular activity related to engineering that you think you will enjoy.